video will help you quickly set up the LDxCHA series of laser diode drivers for your application. This laser diode driver delivers low noise and reliable stability in applications such as materials processing, industrial laser cutting, and laser diode bars and stacks. It is compatible with Type A and Type B lasers. Always observe ESD precautions when handling the driver and laser. For more information on ESD, see the application note on our website. Prior to operation, determine if it will operate within the SOA or safe operating area. Our website also has a video tutorial on using the online SOA calculation tool. Wavelength recommends using a test load prior to operation with a laser diode. This will allow you to ensure that all connections are correct without putting the laser at risk. These drivers contain 5 spring-loaded terminal blocks for easy wiring. J1 contains power supply input and laser diode output connections. J2 contains modulation input, enable, and monitor pins. J3 contains set point, current, and power monitors, each measured with respect to ground. J4 connects the photodiode when operating in constant power mode. J5 is only used for dual supply operation when the laser requires more than 3 volts. Connect a plus 5 volt power supply to J5 for the control electronics and use J1 for the higher voltage to the laser. There are 2 sets of dip switches. One set configures constant current or constant power mode operation. The second set is only used in constant power mode to set the current range for the photodiode. The options are 500 microamps, 5 milliamps, or 100 milliamps. Choose the setting that maximizes the dynamic range for your photodiode. There are 2 onboard trim pots. One configures the current set point, the other sets the current limit. The set trim pot sums with the modulation input to create the final set point for the laser. There are 3 jumpers. JP1, when installed, ties the modulation input to ground. Use this for noise reduction if modulation input is not required. JP1 must be removed if external modulation is used. JP2 ties the power supply inputs together. If JP2 is installed, the unit is configured for single supply input and only a 5 volt power supply should be used. If JP2 is not installed, the unit is configured for dual supply operation. Up to 30 volts can be input to the laser on J1. J5 needs a 5 volt supply for the control electronics. JP3 ties the laser diode anode to the photodiode cathode for constant power operation. Check your laser's datasheet to see if this connection needs to be made externally. Before beginning, collect the following equipment. Our first example uses single supply operation with no modulation input. Install JP1 and JP2. We will operate in constant current mode, so the dip switches must be configured as shown. Without power enabled, connect the positive cable of the power supply to V+ and the negative cable to ground. For all J1 connections, Wavelength recommends using twisted pair stranded wire. 18 gauge wire for currents up to 5 amps and 14 gauge for currents greater than 5 amps. Next, connect the test load between the laser diode anode and the laser diode cathode terminals. Now zero the trim pots. Both trim pots on the unit are 12-turn trim pots where clockwise rotation increases and counterclockwise decreases. A full 12 turns counterclockwise will zero both trim pots. Note that the trim pots will continue to turn after the 12-turn specification, but no additional changes will occur. To monitor the values that are set by the trim pots, the voltmeter will need its positive terminal on one of the monitor pins and its negative terminal on the monitor ground. For purposes of this video, we will leave wires connected to each of the monitor pins for easy monitoring of the various settings. Leave the enable pin floating and turn on the power supply. Once power is on, set the current limit and the current set point. If the current set point begins to approach the limit, the driver will clip the output to the limit without disabling output current. To set the current limit, connect the positive lead of the voltmeter to the lim-mon pin and the negative lead to one of the monitor grounds. The transfer function for the limit monitor can be given as shown, where V is the measured voltage at the monitor pin, Ilim is the user-defined current limit, and Imax is the maximum current allowed by the LDxCHA model. If we are using an LD5CHA, that makes the measured voltage 2.5 volts, meaning that once the voltmeter reads 2.5 volts on the limb-on pin, the current limit will be set at 5 amps. The set point transfer function equation is the same as the current limit equation, with a substitution of I set for I limb. If operation at 3.76 amps is desired, then the voltage measured between setmon and ground should read 1.88 volts. We are now ready to enable current to the load. This is done by grounding the enable pin. Once current is enabled, use Imon to measure a voltage proportional to the current through the load. Again, the transfer function looks similar mathematically with the substitution of IOP for I set. So, with the positive terminal of the voltmeter connected to the Imon pin and the negative terminal to ground, we should see a voltage of 1.88 volts. We have successfully configured the LD5CHA to operate in constant current mode with single supply operation. Next, we will discuss an example involving dual supply operation for higher voltage available to the load. For dual supply operation, JP2 must be removed. A 5-volt supply is required to power the control electronics. This supply will have its positive terminal input to plus 5 volts on J5 and its negative terminal to ground. The higher voltage supply, up to 30 volts, will be wired into V plus and ground on J1. The voltage available to the load will be 2 volts less than the voltage from the higher voltage power supply. Configuring the operating parameters is the same as shown in example 1. As a final example, we will show the effect of a modulation input on the LD5CHA. For this, JP1 must be removed. The modulation input sums with the onboard set point to create a final set point. For this example, set up the function generator for a 10 kHz sine wave with an amplitude of 1 volt for 0.5 amp oscillation around the DC set point of 3.76 amps. As seen on the oscilloscope screen, the output of the LD5CHA is now modulated with the same waveform as provided by the function generator. There's more detailed information in the LDxCHA datasheet. Our website also has tech notes, app notes, and FAQs. Our goal is to help you succeed. If you have any questions, contact our technical support engineers. Consider us an extension of your team.